Let's get started. Elias, we're really happy to have you here today because you are touching to a topic that we are all super curious about, and we haven't seen so many brave hearts tackling that area. For us,
Yeah,
why don't we get started with you introducing yourself as a human being for the ones that haven't got to know you
yeah,
yet?
cool. Yeah, I'm Elias, or how you wish to pronounce it. I am from Sweden. I'm 23 right now. I dropped out of university to start my company. Yeah, my background is basically just like I'm self-taught in literally just everything. I went to university because I had nothing else to do, and I sort of realized that I was wasting my time. And then I started my company. That's like pretty much it. So I come from like a small town called Mölndal or Eklanda, which is like a bit outside of Gothenburg. It's not much else to say there, honestly. Like, yeah, I moved here to the Bay Area and the SF for YC, and I've been here since then, I guess.
Yeah, actually, what struck me was when I take a look back at your background, Sweden, small town, but then you had this really super pretty picture with your father that in the Bay
Yes,
Area when
yes,
you were a kid. It sounds like you had little bit of the seeds in your head, like at the
yes.
earlier days, right?
Yeah, so when I was like 9, 10, or whatever, around that age, I wanted to be an inventor because I didn't know what a founder was. So it sort of started off with me being like, I wanted to invent these things. I started like taking apart my toys, and then there's a whole other thing. But uh, I started tinkering. I wanted to be an inventor. Then I sort of found out what a founder was. And then about 9 years ago, I think, I went there on vacation to San Francisco with my father and my mother, mom and dad. Um, and it's
Oh.
sort of like serendipitous that I sort of just ended up here because I remember like really enjoying being here in San Francisco. Back then, I wasn't like entrenched in like the tech culture. I was just a kid. Um, but it's sort of like I went here and it's sort of like the SF bug like slowly creeped into my head and it's been growing ever since. And then
Mm.
I, yeah, had to move here.
First time when we talked, and you told me that this is the only place I want to be right now on the earth, and this is I don't want to
Yeah.
be anywhere else. Like it was really quite like convinced tone. What was not like
Yeah. Like, I mean,
wherever I go. Mm.
Silicon Valley is like weird. Like people will share you on for doing the most like the most ambitious thing ever, even if they think it's stupid. If you go to Europe and or like Sweden is my paradigm example. Like people will look down upon you, like they'll try to like bring you down because you're different, and
Mm.
that's like extremely draining. It's like you can't really grow from there, and you sort of have to fit in. Then the people actually like who like supersede, I guess the immense peer pressure or Jante Law again, as people call it. It's sort of like the people come out of Sweden, like the technical talent, the founders are really strong because they survive this hellscape of like you're not welcome here. You're too weird, basically. And they always usually they just end up in San Francisco. Then there's a tech hub in Stockholm that's doing really well. But at the end of like every single founder out of Sweden is really weird and they're really strong. And like when I talk to VCs about it, they're like, "Oh, we want to look at the Nordics now because of this like hellscape, and the people who survive it are really good for some reason." So I do really think that like yeah, hardship trains the faithful, I guess, whatever the saying is.
It is sometimes a little bit makes you feel unfair, kinda, because actually you're just in a different like it's not like if you fit in or you don't fit in, but it's just like your environment is similar. I had a professor in the university. He once told me this is like taking a kitten and putting it into puppies. Then that kitten will
Yeah,
think, "Why am I not barking? Why am I not strong?" But actually, the place that that kitten belongs to is next to the other kittens. Not. I
yeah.
think this is a little bit of similar to that. It
I,
always makes me think.
Yeah, like I mean, environments are extremely important. Like we humans, we adapt to our environment, and if you're fundamentally like not supposed to be like you don't really fit into a specific environment, there's going to be conflicts. You're not going to be happy. You're just going to be depressed, and you're just going to try and like walk around, and then eventually you're just going to break. So it's really important just to find the environment where you really like flourish in. For me, it's San Francisco. For me, it's like tech in Silicon Valley, like building deep tech, like a deep tech company. For others, it
Mm.
might be like, I don't know, what is the finance capital? It's like London or New York. If you like finance, go there.
Yeah.
If you like art, I have no clue where that is, but I'm not, yeah, doesn't matter. If you like those
Yeah.
things, you should be in those places. But if you really want to be in tech and you want to do these, like, you want to build something like revolutionary in tech, you have to be in Silicon Valley because that's where everything's happening. And that's also why it's sort of like a magical place.
I think I totally get you, and probably many. audience will also resonate with that. By the way, we had an audience of like a really great mix in terms of university students as well, but at the same time, professionals like who has accumulated some experience, and builders and researchers. Like we had a very pretty wide range of age at the same time, all coming around the deep tech and building hard stuff. But among all the other topics, subjects, how did you end up in chips?
And chips. Well, I've always been interested in computers. It's like literally the only thing I like been interested in since I was like 10. Like, sure, I made my like side inventions of like making whatever, but it all started from being like, I've always been interested in computers and computing in general. And that's sort of like snowballed into being interested in mathematics, and that's just snowballed into being interested in computer engineering. But the point of computer engineering is to try to give this machine to the mathematicians or the physicists or the statisticians or the AI people to be able to do these amazing things. And it's sort of like the sense of like, it's like a tool to basically accelerate our own intelligence. It's like you move, like if you have a simple calculator versus you have a supercomputer, you can do a lot more with a supercomputer. And I think sort of like that's what I realized. And when it comes to like why I like chips and computing and like computer engineering, computer architecture, I don't know. I mean, I was really obsessive. It just sort of happened, to be honest.
Do you have moments in your mind that when you really recognized, okay, this is the thing that I need to pursue, and I try to understand in depth?
Just never like, oh shit, I gotta do this thing. It's more like successive, like accumulative evolution throughout time. So it started with me being like, I kinda like computers, I like video games, I wanna build my own video game. And then it started with me tinkering with like when I was very young with my own toys and like taking them apart and doing all crazy whatever. That sort of just like snowballed into this direction, and I just kept following the things I'm extremely interested in, and this is the place I ended up in. It's like, yeah, I have my own company, whatever. Like, this is not a job for me. It's not work. Like, I'm having fun every single day. Like, just follow that instinct and you'll be good.
Yeah. Okay, then actually we can phase into now ZettaScale. Like
Yeah.
I've been following your work ever since you popped up on my SIS company directory. And then you guys had a little bit of like changes with the name and with the papers. You thought, oh, we have a more advanced way. We're going to update this and so on. Perhaps let's get started with the very big picture. How do you see the industry right now? And also, what's your vision? And then afterwards, we can work backwards from there to today, and then take it to the specifics that I have in my mind.
What it looks like right this very section for AI specifically is we have this huge like LLM boom, like ChatGPT and Claude Code, all those sort of like language models. And then we have all of these vision models, and we have Midjourney and all these sort of like modalities that's like we have basically infinite data of like the whole internet. It's what the internet runs on basically. And this exploded because they started scaling really well on GPUs because they fit really well onto GPUs. That's not a coincidence. That's not a mistake. That's more like that was like more probably than not bound to happen sooner than later. So what Nvidia, AMD, even Google with their GPUs, they're sort of like speed running into this like LLM direction of trying to make the best frontier model, the best chatbot, the best like companion, like everyone's speeding in this direction, and then you have companies show up like Grok, Cerebras, and a bunch of other companies like trying to make like LLM specific chips. So everyone's like double focusing on this thing.
Yeah.
But then we sort of forget the point of AI, and the point of computing is if you're sort of focusing too much on this one thing and you're betting on it, you're sort of neglecting everything else. So I usually say AI is not a bubble, LLMs are. And that's very hard for some people to believe because they've deployed like millions of dollars of capital into LLMs. But I'm not saying they will be worthless. They'll be worth hundreds of billions of dollars, maybe $1 trillion. But when it comes to the future of AI, that there's more to AI that we can actually do, and we only scratch the surface. So what I'm predicting what the market's going to be like is like, yeah, sure, Nvidia's rushing to make GPUs and do all of these cool things, but what essentially the market needs, they need versatility. We need to enable the AI people to do their actual research. That's the whole point of computer engineering in the first place, right?
Correct.
We give them the machine to model their mathematical models or whatever they're trying to compute. Without that, and we force them to go in a specific direction, also called the hardware bias, they'll essentially end up kind of blinded by that, and then we'll have a diminishing return, and people are starting to notice that now. And then people's going to be like, oh shit, no, AI is a bubble. It's not. It's just these people betting a lot on this specific thing. And it's going to be very important in the future for like agentic workloads. But if you're doing more discovery, like in material discovery or protein folding, like what DeepMind did, you know, you have to be smart. You have to support those. You need versatility. So that's why ASICs, as they're called, I don't think they're the future.
But you are in a place, in order to really nail it, you need to have your very own AI vision for the AI models, vision for how this is going to continue, and also
Yeah.
the vision around the co-design of hardware and software, right?
Yes.
And
The only
this is,
company I would say is doing like, well, Nvidia has your AI whatever department. What the companies that are doing really well is Google DeepMind. Like they have DeepMind, they actually have frontier research. They have this communication layer with the TPU team that we sort of need this thing. Could you please like help me? That is the most important part. If you don't have that communication, you're just going to end up with a company filled with hardware people thinking that the hardware is so amazing, but then you sort of push out the hardware and then the compiler becomes like, depending on what the hardware is, like mega complex, and all these ML people like, I don't want to deal with this shit. And then you sort of like have a really cool hardware project that's like an art project, but it's kind of useless.
But actually,
And
Google is one of
yeah,
the school of it. If you take a look at it, right? Because also the startups that get out of it, including Grok, was
yeah,
also from Google. And there you also can see this reasoning is very strong. And then they look at it more like a entire ecosystem and in a place where they can make their differentiation and double down on it rather than, hey, let's
yeah,
cover everything and nothing. Because so far it worked for Nvidia. Like, correct me if I am wrong. It
yes,
was, of course, if they started with something again back then nobody had seen
yes,
coming, but it then turned out to be an AI enabler. And
yeah,
afterwards, now, but also it locked down the entire industry. Like we're talking about a company like who is the worst,
yeah,
most valuable, and 92% of the market share belongs to them. If actually, I remember a conversation around CUDA, how such a big
yes.
lock in.
There's two parts to this actually. I'll get to CUDA later. It's not a moat, by the way, if you want to keep listening. So yeah, sure, you have Grok like spinning out of these companies, and they're making this bet on this whatever, like language models basically. I'm not saying that that's going to be useless like in the short term. That's going to make a few $1 billion in the short term. Like they got acquired or like made a license deal for like $20 billion.
Yeah.
Cool, great for them. But it's also the difference between $1 billion and $1 trillion. If you're limiting yourself and the whole of like humanity and the future of humanity to these transformer models, like what are you doing? You want them to like write more emails and be better writing my slop AI vibe coded app? Then that's not really the future of humanity. If we do that for the next 100 years, then that's going to be depressing. So yeah, this like with Google and DeepMind, they're sort of on the right track. I think they're too big of a company to make like a revolutionary step in the hardware direction unless they do something very like a major restructure or something. But yeah, and then when it comes to CUDA, it's simply it's not a moat. Sure, Nvidia has this massive market share, but if you, like, okay, so if you go and ask the machine learning engineers, AI engineers, do they like writing CUDA? Is that productive? No, it's not really productive, is it? Their job is to basically create a model that fits whatever data set they have, how it work, and having to optimize every single model to their, like, with writing CUDA kernels. You sort of are bottlenecked by the actual hardware. And then when it comes to the actual, like, well, okay, so what's the replacement? Like, what's the background look like? So just because CUDA is currently the best thing on the market doesn't mean it's great.
Yeah, that is, I think,
That
similar
is a major
to.
part. Yeah.
Yeah. I think my point was more into the ecosystem view in a way. They
Oh
cover
yeah,
it
I'm getting to that.
end
I'm
to
getting to
end.
that.
Okay,
So
okay. I'm
that is the
patient. I'm gonna be
first
patient.
part. So people are suffering. So what we are seeing now is that the entire like machine learning community, like they don't really want to write these kernels. They just want to sit in PyTorch or JAX and like, oh, it works, cool. It's mostly abstracted away from them. The people who are writing these kernels are kind of wasting time in my opinion. But when it comes to the entire ecosystem, what we're currently seeing is a major like incentive, like this massive incentive structure to move off of CUDA, because people don't want to be vendor locked by Nvidia because they have massively inflated prices. That's the first part. Also because they have this huge hardware bias with GPUs and they're really hard to like not hard, but it's not fun, I guess, unless if you're really weird and like you like write CUDA kernels. So this is massive incentive structure to just get away from Nvidia. OpenAI went to AMD and Cerebras recently, and all these other companies are trying to like go to AMD, and ROCm is like flourishing. And what if you look at the entire ecosystem, this has sort of happened before. So we're all moving to this open source ecosystem. MLIR is doing really well. This is like the backend for machine learning compute. And same because everyone has this incentive, it's slowly accumulating. The open source community is slowly building up this open source standard, which really just benefits all of the labs, which is essentially the end customer, or even the hyperscalers, because they don't have to deal with like this software hell, and CUDA as a moving target, and they have to be backwards compatible, and it's proprietary, so you can fix it yourself. And we all know how AMD handles software, and if Nvidia slips up, like they're done. So for CUDA to actually be relevant in like 10 years or even like 2 years, they either have to open source it or they'll have to, some open source thing will just take over. And that's like the reality of it.
How do you see, let's say 10 years forward we went, like 10 years forward, like how do you see the overall picture of work? It's like more architecture agnostic, it's more in the direction of highly specialized, and then more
I envision like the way you do modeling today is like you actually define your model like declaratively, like this is my model, this is how it's structured. Like if you define a transformer model, you define the transformer is going to be like this, XYZ. Your like your compiler or basically your hardware is the point of it is to basically be able to represent that model as closely as possible. And again, coming back to that, you sort of need versatility for that. But if you have too much versatility, like an FPGA, you sort of like the compiler is super complex and all those sort of shit. But coming back to CUDA and why the open source thing always just wins, it's just an open source model, because your end customers are developers. And what we really saw before, and if you just look at the history, what won? Was it Windows, Unix, or Linux? It was obviously Linux. Because there's this massive incentive from like a bunch of players, like decentralized players, to actually use this thing. And it sort of created this like open source community that's really strong. And then I know Microsoft is trying with like Windows Server. Like, is anyone using that? To be honest, that's like, yeah, okay. And it's mostly like if you're making something for developers, you sort of have to be open source, like on the software end. Like, if you show up with something proprietary and yell at them and tell them like, okay, you gotta use this thing. Here's the documentation. Good luck. Like, if they can't fix it themselves, like the whole point of being like an engineer is being able to fix the thing that you're actually working with. And if you're constrained with something some big company's telling you to do, then you're not going to be happy with that. And that's another incentive to like just move off CUDA. And it's basically just technical debt in the market right now.
What do you think about the switch cost? Because right now there are different point of views, but in the end of the day, what is working is Nvidia's ecosystem at the moment,
yeah.
right?
Like it won't happen overnight.
And, yeah, exactly. And also there is something called inertia. When people come across with something new, not everyone is open as you in the way that you approach things. This early adapters piece that you need to get, like how are you going to approach this? And also what will be your differentiation so that you promise them something so amazing, they won't even think of the what they have in their mind. They will just drop and come with you.
In reality, if you show up with the world's best chip and your software is like utterly like horrible, no one's going to use it. That's what happened in GraphCore, right? Even if you show up with the hardware in the world with the worst software, obviously no one's going to use that. And if you show up with like mediocre hardware, like worst hardware in the world, okay software, and it's currently the best software out there, then people are going to use that. That's literally just Nvidia. So it's really just a curve. So like, yeah, the early adopters won't be like these mega huge hyperscalers from day zero. It will be researchers. It will be people doing this frontier edge research, basically scientific discovery with the help of AI. Small startups, like people willing to actually try this thing because they're basically small, they can try it. And what you basically have to do, you sort of have to traverse the curve up and then reach more and more people. But as for our go-to market or whatever lingo you wish to use, is we're basically seeding our chips and our ecosystem in these small number of people. And then over time that the ecosystem develops. And it's not like we're developing our own software ecosystem, because that would be stupid, because MLIR already exists. They like the OpenXLA project is like, it exists. People are using it today. Like if you ever use JAX, for example, they use fighters, just that big evil blob thing, but that's another story.
No, but actually then you aim for really ahead of the curve folks, and most of the times these excited people are doing novel work, right? So then you're not just really going to very established companies, AI folks that building in that space. Rather, you go for after the researchers or startup folks, and actually you kind of draw parallels to the ecosystems. You're not just trying to boom and then get bigger. No, like you're going hand in hand, and then slowly you just get more stake. Did I understand you correctly?
Exactly. Yeah. So like it's cumulative, like it's compounding over time. And that's just the ecosystem part. So a small short thing about our hardware is it's meant to be as versatile as possible, so you can fit your model into the as best as possible. The good part of that is, like, as we're developing the ecosystem, more and more people at the same time, these early people, because they are on the frontier literally, will have more and more people making like breakthrough AI papers like attention is all you need. It's going to go viral. And over time, we'll end up with 2 more, and then 5 more, and then 10 more, and it will be a compounding effect until we have such a Cambrian explosion of AI research and possibility that I said I was at like an event yesterday where I spoke. It's like it's going to be a Cambrian explosion of just AI progress and research, and that's going to have an extreme compounding effect on literally every single industry. Not only like writing emails and doing accounting, it's going to be affecting material discovery, like space technology, like literally every single thing you can think of will get so accelerated that the future is going to be massively insane. Like that's a future I really want to live in. And that's like, we're heading in that direction. And I have this privilege, like I'm literally on the frontier working on this. And that's like the best feeling in the entire universe, to be honest.
Hey, this is what you wanted yesterday even, right? Like that's why you're so impatient, like, hey, this needs to come today, like immediately. At the same time, when you collaborate with those folks, you co-build your product together with them, which gives you also advantage, because you don't want to just drop something to somebody and then you don't hear something back, or you don't have shared the same enthusiasm. Is that also a part of your approach where you aim for small teams? There's no like overhead, there's no the decision making trouble, and also results speak for themselves. Because imagine if something happens in science space and then you are a part of that success, and then this is gonna be much more effective than only, let's say, cost conversations, or only I'm gonna replace, I will have my productivity x and x. But in that case, you kind of like being a part of a breakthrough. What sort of folks are you looking for right now to co-build your product together, to be more specific? Like, okay, researchers, any specific area, any specific...
Anyone doing any sort of frontier edge AI research. Like the most people I'm talking to is like, oh, I'm doing this like in like biology, like research stuff, whatever. And they're like, I'm trying to run this new type of model, and it's not really running well because I'm doing this crazy thing. Could you please, like, can I try it on your thing? Like people who really need the versatility to be able to scale their models. So most of the AI research is already there. Like everyone's doing all these sort of like toy problems, and what the missing key part is being able to scale the model to such a scale, and literal like volume scale in parameters, but to a scale where it's actually useful. Like ChatGPT started off at like GPT, like that started off as something like kind of honestly useless. But then sort of like someone figured out how to scale it on GPUs, and then, oh wow, cool, now we have a multi-billion-dollar, like trillion-dollar industry, I believe soon, just from that direction alone. And there's like, this is one direction. There's like hundreds to thousands of new like AI papers out there that's yet to be written, yet to be scaled. And those are the sort of people like we like partnering with. So yeah, we basically have a list of like everyone who's like want to test it out. We have our own cluster. We call it the Monolith from 2001, that movie, with our prototypes in it. So what we usually do is like send us your SSH pub key and you just try it.
Have you ever said, we are not a good match? Like folks reach out to you or you had the conversation and then you realize this is going to be more like a slowing us rather than contributing.
Yeah. Like there's been some people like, oh, I'm training this Frontier's LLM model. And it's like, yeah, I guess that's cool, but we really want you to be weird and try to do something novel and new. In reality, we do have limited capacity. We have one server rack and we have limited power. So we can't serve 100 people at the same time until we build our data center, spoiler alert. But that is on to me, like, we have to be a bit picky. Yeah.
Can you walk us through what exactly, like, I know you can't reveal everything, but at least if I am today, let's simulate the environment that we are having a conversation, and then you ask me to give it a chance to ZettaScale. Like, why would I do this? Like, why would I leave my setup? I have my frustrations, of course, but then there is this idea of a switch cost. Like, what is the promise that you give me? And also, what is the reasoning behind your product that is gonna step by step just get better?
Okay, cool. So if you're a researcher, you're doing research, you're either writing code in like JAX or PyTorch or whatever public ML framework. Torch is another conversation, but there's Torch MLIR and stuff, so we do support it currently. But you would essentially just take your code and install our drivers, and that would be it. So all you have to do is click a download button and then maybe the install button, or like just do like whatever distro you're on Linux, like sudo apt install XPU drivers, and that's it. So for the switching cost of your software, like when I spoke with OpenAI with this, like they had the switching cost is like not like, oh, can we swap out the hardware and then play with it? It's a huge like investment for any AI lab to just rewrite all of their code. Which is also why we see all of these other chip startups like Grok, Tensor, who have their own like custom like software stack that they're trying to get everyone to use. But that's the actual major investment for these people. That's where the friction is coming from. As I said before, like if you have the world's worst chip in the world and kind of okay software, then that's gonna sell more than having the best chip in the world with bad software.
That's right. Yeah. I think that was a pretty good example to demonstrate. And how did you end up with your numbers? Because right now you're clearly saying 26 stats. 7 was that?
Those benchmarks are old. We have new benchmarks very soon, and we're just benchmarking like literally every model we can get our hands on. So yeah, that's it.
How do you like what? Because benchmarks that are benchmarks. Like, how do you? What is the overall steps that you do?
For the old one, that was a power simulation of like what is the maximum flops we can produce on our chip and what is the maximum power drain. That's a very simple thing. It doesn't mean that those computations are useful, but it's the maximum peak of the old chip. What the benchmark we're doing now with our compiler is that's also using MLIR. We have a profiler, so if you're running like a transformer model, for example, we can see like what is the speed up of X, Y, and Z. And that will always be dependent on how much bandwidth you essentially have, like your effective bandwidth. And then what we actually do with our chips, because they are reconfigurable, not in a spatial sense, as in like we don't take this node and then put them together. What we actually do is we have a different execution model. So when you compute your tensor, like a matrix, you usually do a matmul, and then you have like a nonlinear activation. And then you sort of have to like move all of the matmul results to some other circuit that's doing your activation, whatever. But there's a way to fuse them together to essentially just be in one go. And the less times you have to read from memory and the less time you have to write from memory in those intermediate steps, the faster your chip becomes, the more throughput you get and the more energy efficient you become. So that is what we're benchmarking on like a transformer. Like how much fusion can we do on a transformer given these constraints? And then there's like a bunch of like information dependence constraints, which limits your fusion. But we have some cool neat tricks around those as well.
But tell me more about it. Like, what sort of trade-offs do you take then? Because you can't maximize on everything.
It's basically higher latency. That's it. But if you're doing like large like training runs and even large inference with a big batch size, that doesn't really matter. But if you're doing stuff on the edge, like if you want to have like a, I don't know, running your whatever model on the edge for like a drone or something or on your phone, then the high latency is not really good for that. But as also noted, that's not really the workloads we care about, because we care more about the actual computational things that will lead us to ASI or whatever you want to call it.
You mean the super intelligence?
Yeah.
Yeah. What is the definition of super intelligence for you?
Being able to adapt and getting what you want. I think like for humans, okay, if we get the AI to get what they want, then I don't, that's not do that actually. But for humans, at least, I would think it would be like, there's a lot of very smart people who aren't intelligent enough to sort of achieve their goals. And they sort of like blur down in this one direction and they get stuck, and then they like obsess over details that doesn't really matter, and then they waste time. And then they end up writing 50 papers and they end up with a PhD and that's it. Versus someone who actually built something that's very useful for a lot of people and you move the needle for humanity. That is the major difference between the two.
Are you following certain folks' papers like regularly, religiously, like whenever they publish certain things and then you get your hands on it?
I wouldn't say specific people, but within the company, we're just like, oh, we see a cool paper and we send it in the Slack channel. And everyone's like, oh, this is kind of interesting. So we just have this like, oh, if something cool appears, like, cool. I don't really believe in like that this magical figure will produce the best AI papers. And in most cases, it's the people you expect the least of, like the misfits who actually come up with these like revolutionary things. It's not like the big famous AI guy, unless they can still do it, but it's always going to be someone unrecognized because they have something to prove.
Yeah, when it comes to facts and truth, like it doesn't come with any sort of chip on your shoulder. Like if you got it, then you reveal it to the world. Totally agree. At the same time, like there are certain people, for example, I'm always curious to take a look. Like, oh, what did they do? If I come across with it, then my first instinction is not bookmark go. Okay, let me just quickly take a look at it. That was more the intention of my question.
Oh, okay. Oh yeah, well, when I say papers, I just read it, because if I have a stack of papers, I'm never going to read them.
Yeah.
Like if something takes you like 5-10 minutes to do, you just should do it straight away. Otherwise, you're just going to forget it because you won't care as much about it, right?
Yeah, but actually, when you speak about your Slack channel and the team, right now you guys are 4, right? Like
we're 5 people.
Yeah, 5 people. 5 people. And how do you see the pace? How do you see your milestones? Like you set your goals, milestones, and how do you see all the building team at the same time and building the product in parallel together?
It's not that we build it in parallel, it's that we build it. So one major thing we have at Zetta is like, we don't have roles. I think roles are the most cringe thing ever. We don't have specialties. We're expecting everyone to basically learn everything, like the whole stack. If you join in and you know this area really well, then yeah, you should obviously work on that. But you should also learn the abstraction layer above you and the abstraction layer below you. Because if you don't, everyone's just going to get very like compartmentalized, and we're not going to be aligned at all. And that's just bad. How I structure my team is we have it all the way up to the AI researcher, all the way down to the silicon. And that's really important. It's sort of like what Bell Labs did back in the day. Like if you sit next to the guy, or like the person in either of those abstraction layers, and you do something really like a design choice is like really stupid, they can like look at you and like, why are you making my life hard, mate? Please don't. And the reverse is true as well. So if you do a really great design choice, they will like cheer you on. They'll like, hell yeah. Having that communication is extremely important, which is also coming back to like Google DeepMind, which is why I think they're great, but they also lacking because they still have this huge corporation that's compartmentalized. So the only sort of way to have that is like just have all those people in the same room sitting next to each other, and that's it.
But then at the same time, how do you now set your goals? Because what you're tackling is not like, how do you say this?
Yeah,
I'm automating finance departments of billings, like
yeah,
billings, or I am happy. Do you know what I mean? Like,
it,
it's not like a regular SaaS.
yeah,
Therefore, that you have so many different pieces in the puzzle to always keep them
yeah.
together and choose
They're
the
always
goal.
communication. Like if somewhere in the stack something's like falling off and you sort of have to fix it, then you feel the effect up at like the AI level because you don't do the thing. Um, so really how we set goals is like, it's not that, okay, let's make this huge, perfect product in next month. It's more like, okay, what can we get the most done today? And we sort of like map out on an exponential curve because you sort of have to lay the foundation first to have a very strong foundation. And then you sort of build upon it as you go. As the reverse, if you just like take huge steps and jump forward, you have to take huge steps back and jump forward, and it'll just take more time.
Mm.
So if you follow this exponential curve and you basically just tell everyone, okay, just be very rigorous in the actual foundation of the product. If you're working like on a module for the chip, be very rigorous. And how's that going to affect the above stack? If you aren't, it sort of falls apart. So you sort of have to set the goals on an exponential curve. If that sort of makes sense.
Are you getting any sort of because sometimes when we are doing it on our own, I call it bubble, but
Yeah,
I mean more in a team environment, then you
yeah.
always need some sort of external people, which are in this case your customers, early customers, are to
Yeah.
burst your bubble. Like, and how do you stress test the ideas before investing too much?
We have some sense of like what's needed for AI internally in the company because we're fully
Mm.
vertically integrated with AI all the way to silicon. The only solution is just talk to your customers. There's no magic thing. Just go talk to them. Like I go to random like SF functions and then like meet people there who's working on this new AI lab and we're working on something really cool actually. And I just talk to them like what are your what pains you with the current ecosystem that you're using. And most of the cases, they're like, oh, this GPU shit, I can't scale my thing, whatever. And that's pretty much it. It's just that simple.
And it was my favorite answer I could ever hear. But are you in sort of any partnerships with any sort of other companies where you get help?
But we have manufacturing partnerships.
Mhm.
So like with TSMC, GSME, we're also producing our PCBs here in the Bay Area with Sierra Circuits. We're trying to keep all of the manufacturing here in like in the US. That's pretty much it. Yeah.
Recently I reflected on the fact that when it comes to manufacturing part of the, let's say, chain, and
Yeah.
even there is this priority. Certain companies have certain priorities because of their capital and dominance in the space. Like, how do you see it tackling this piece? Because in the end of the day, it's not like, I go and immediately they give me what I want.
No, okay. So one thing I'll learn is startups are very much internally and externally a people problem. And
Mm.
that's something you can't escape. So even with like the manufacturing and like getting the supplies and the components, you sort of have to like it's very subjective for every single supplier. Some of them wants to talk over Zoom, some of them wants to meet in person, some of them wants to like chat over phone, or somebody just wants to email. It's very diverse of what they want to do. You sort of have to navigate this maze, and then you sort of, because you're a startup, you have to convince them that like I'm important. Otherwise, they're just going to go to like this huge company is going to pay them a lot of money, and
Mm.
like you more problem than not, you get like the worst team on their end that's going to deal with you, and then you sort of like have to like fight up and like just fix everything. So you sort of have to. I think the word I keep using, like everyone in the team's like trying to talk with suppliers and stuff in parallel. I
Mm.
tell them to be annoying, as much as annoying as like be annoying. If you're not feeling annoying, then you're sort of like not putting in the effort, right?
I think you try to annoy them in a good way for your own.
Okay, we don't try to annoy them, but it's more like you have to like follow up to an extent where you think you're being annoying.
Mm. Mm.
So yeah, that was it. Like we had this like a few weeks ago, like this one supplier like just wouldn't reply to our emails or they wouldn't answer the phone. So we just had this idea like, okay, just take an Uber down to your office and like chat in the lobby. Which coincidentally, right when we said that, they responded, so we didn't have to do that. It was great. But if it requires you to like go down to the office and then actually speak to the key people that are there, just do it. I would also avoid like getting like a restraining order. I don't think that would be productive, but there are limits, of course, but like you sort of have to be like, keep knocking on their door, like because people, like, if they don't care, they're going to forget, and that's just a human factor.
I think one of the stories that I remember from Chapol from Entangle from your batch, and then
Yeah.
he was talking about he was sending cakes till the
Yeah.
person responded him, and he was like, "Just stop sending me cakes. I'm gonna respond what you want. Like just stop doing this." Or even they went one step ahead, and then they put a billboard
Yeah.
in front of the company in a way like, "Will you
That's
answer
funny.
us?"
That's funny.
And we were like, "That's the spirit."
Yeah, he's a
But I
great
did
guy.
like the conversations where you see how much of care is in there. Like nothing else would make you do this. Like I don't
Yeah.
believe in monetary motivation when someone tells you such stories. In your
Yeah.
case, like, why would you care? Yeah, why would you care? Like, why would you care so much about this specific?
Like me?
Yeah, you as a
Yeah.
person, like it's one thing to be
But
interested in, and you know that you have a talent, you have an eye for it, but then another thing
yeah.
is like you really care so much, and then you move it forward and try to
Yeah.
make something that's gonna change people's lives.
Like talking with a supplier, or
Hmm?
like talking with suppliers and manufacturing people?
No. Like overall for you, Elias, like
Overall, oh, okay.
why do you care overall so much? Like you could have just gone to it, like you could have still tinkered in so many different ways. It didn't have to
Yeah,
be
yeah, I think
this
it's two parts. The first
structure.
part is like my own personality. I'm extremely obsessive. So I think that that's a major part. But the main part is like I am like, I can see that one of the main hiring questions I ask is, what do you think the world is going to look like in 10 years? And what do you want it to look like in 10 years? Or are those the same?
Mm.
And if you answer like, I think it's going to look like something horrible, and then you answer, okay, what do you want it to look like? Not horrible. And then, okay, you sort of like are lacking the point. But my point is like, I envision this future in 10 years where we basically have this abundance thanks to AI, and when the only scarcity that's really left is this like scientific discovery part. And for me to care about this, is more like I really just want to build a future for all of the people I really love and all of the people I care about, because they deserve it. Like
And
that's it. Like, okay, sure, I can be like, oh shit, I want to become a billionaire. Okay, why don't you just go work in finance? Like, what's the point of doing this then? Like, the point is actually changing, like putting a dent in the universe so you can make the universe a better place for the people that you love. And if you're not really doing that, you don't have to do it in tech, you don't have to do it in whatever. That's really the point of everything, right? Just leave the things as you found them in a better place. That sounds like very cliche, but that's just the truth.
But it's like also among all the stories and novel motivation behind everything you do, there must be some moments that it got really tough too, right? Like did you guys have this
Yes.
near death moments and also adopting and trying to see, okay, like we just need to get over this and then probably it's gonna be better. Like let's talk a little bit about those moments.
I mean, the only real failure is when you die, right?
Mm.
Everything that keeps you, like, if we do a mistake and whatever, as long as we don't die, it doesn't really matter. As long as we learn from it and then move forward. Like, there's gonna be periods where you feel like this gut wrenching like pain of like anxiety, and like you really like, it's extremely comfortable. But like at the start, it's like sort of less, and then as you go progress forward, it's like you don't really get used to it, but you get more tolerant to it, and you become more and more resilient. It's like
Mm.
from my past, like hardship trains the faithful. Like, it's not like I magically like spawned and then everything was fine and then I magically appeared in this position. It's literally just constant suffering. That is what it's like when you build a startup or when you build a company. It's just constant suffering. There's no glamour to it. And like to keep going if things are tough is like, like I don't, giving up is cringe. I don't know why people do that. Like it's fundamentally like I don't get it. Why would you do that?
in context it changes, right? Like for some people, when they give up, they find the next thing that is the right match for them. Some they don't give up and then they persist on the thing. I always say, like, sometimes you don't know what you do, but you at least know what you don't want, and then you start experiment. And if you drop one experiment for a better experiment, actually it's still not really quite giving up, but it's a definition of giving up, right? Like how we should define giving up.
It's if you're pivoting, then it's like you're pivoting for a reason, to find something better.
Yeah.
But like for me at least, like I have this vision of the future, like this is something I really need to work on. It's sort of like I have this my own personal mission that I want to fulfill. I know my own purpose. I know I need to do this. This is why I exist. So like for me, like giving up, it's not an option. I don't see why I would do that or anyone would. And that's also me being like kind of failing to see other people's perspective, because I've always been like this. I've always had this mission in my head that I want to improve the world in the way I think it, in a way that I think is good. But the semantics between of getting from A to B doesn't matter. So if you start like with our chips, we started doing spatial reconfigurability. Over time, we sort of realized that was not a good approach to what we're trying to do. We then realized that makes too big of a chip. You can't make many of them, and you end up as like Cerebras or something. Make one chip a year, and then you can sell them. So it's not about like the definition of giving up is like you give up. I'm not going to do this anymore, etc., etc. But what you really should be aiming for is like, okay, if something's not working, figure out what's not working, and then basically evolve from there, like build on top of it, like remove the things that's not working and then build. That's like the core thing of how you keep going forward. And like pivoting for like SaaS companies, I guess, it's like, oh, we have 1 million ARR and we're sort of stuck in this growth. Like we're plateauing. Who am I to tell you to pivot? But if you want to reach 10 million, 100 million, you got to do something, right?
More or less. Then I have an assumption that you look into this resilience factor a lot in your co-founder probably as well, right? How did you guys meet? How did you had this click?
That's a funny story. I was still in university. This VC invited both of us and a few other people to like conference thing for a week in London. It was at a girls' boarding school that they rented out. So we just met there, and then we like just started talking about like the future we really want to build and what's really needed. And I remember my co-founder's name is Prithvi. I remember like meeting him, and the first thing he said, like there's something here. There's like something like on the tip of our tongue. The first thing. And we just like took a walk around the compound. Basically, it was like good nature, like good whatever, quite a beautiful place to be honest. And we just sort of started talking about that, and then we were like, oh wait, this is like, yeah, we should do this. And then that's when I met him, and then I was still in the UK. And I fly back, and then a few months after that, we got into YC. Yeah. No, actually, we used to call it like co-founders at first sight.
Ah, cool.
Because we just like. We both got our own visions, like that like we're I'm basically the computer architecture, and he's basically the AI researcher. Like this duo doesn't really exist, but because typically the AI researchers hate the hardware people.
But this is the perfect combination for what you're doing, because you need to have the vision and understanding, right? And
that's how we model the company. Like we're keeping this dyad between the hardware people and the like AI and software people. It's something you gotta have. Like you can't remove some abstraction layer and then hope that your customers will love you. You sort of have to. This is the communication part. This is why Bell Labs was so good back in the day. It's something we're emulating. You can't just be this tunnel vision on this one thing. That's why all of these other chip companies are sort of like, I don't know what the hell's happening with them.
I realized that I am really enjoying the conversation, but probably Cameron is also waiting for us to prepare more questions.
Firstly, thank you a ton for the conversation. It was really interesting to just kind of, sit there and absorb and learn, to be honest. And I like the fact that everything tied back to making the world a better place for the people you love in the future that you want to see. I thought that was...
Yeah. Have you guys seen the TV series called Silicon Valley, when everyone just keeps saying like, we're making the world a better place, and then they spew some tech bullshit? Yeah, I kind of see the irony, like, oh yeah, we're tech pros. I don't call myself a tech pro. I'm a deep tech bro. I do deep tech shit. Right.
There's some merchandise in that, I'm sure, somewhere.
Yeah.
Yeah, absolutely. I always enjoyed that, and they ended up just creeping like slowly, steadily back to like the standard server rack after trying to like create so different.
It's like we were making like bit soup, and we're making it all over the place.
Yeah,
probably. Sure.
Nice. So what I'll do is I'll run through a few of the questions that were either sent through beforehand or that have come through on the chat. So we have one from Axel, and his question was, what's your thought on in-memory compute like neuromorphics? Is it something that is interesting to explore? Just wanted to get your opinion on that area.
I think in-memory compute, like everyone's doing that now, like everyone's spamming SRAM everywhere. The problem is you have this memory or like memory bandwidth inflation. You sort of not thinking about how you do the computation. Mm-hmm. So the key part of our philosophy is like if you can fuse A and B together to sort of reduce the data movement, you sort of have this compounding effect as well as you scale your memory bandwidth. It sort of becomes an exponential rather than a linear increase over time. Doing in-memory compute, like it has its advantages, it has its disadvantages. Like you end up with a very big chip, and then your yields are really bad. It worked for Grok, I guess, and they made a cool demo. But apart from that, if you need versatility, like reconfigurability and versatility is quite the most key factor here.
Okay, perfect. And then I think one of the topics that has come across, obviously, with a lot of the previous founders that we've had on is, how did your experience at YC shape you?
Yeah,
I think if I listen to kind of some of the parts, one thing which stuck out, which seems to be maybe to me a holdover from YC and other people's comments, is just get in the room, just be next to the people that you need to be at, because at YC you've got everyone and you've got this intense network and kind of competition with the people around you, obviously, which may not be the same within the company, but just this idea of getting the right people in the room so they can be having that short feedback loop. But if you could expand on that, great.
I mean, at YC, like my personal experience, like I came from like university, from a small town where I'm sort of like the only person who really cared about tech startups. Like you sort of find your flock, I guess, or whatever it's called. Like when I got there, I felt like a huge relief, like a huge weight lifted from my shoulders that I had to like conform and I could just be myself. And it's like true for Silicon Valley and SF in general. Like they just be yourself, and like people will cheer you on. It's like a magical place where that's happening. It's insane. But like even like in YC, like Paul and Philip and Brandon, like you're always seeing them making progress, and then when you're doing something bad and you're like lacking like performance, you sort of see that directly and sort of like, oh shit, I had to catch up and I have to like double down. And like having like very like high quality founders around you is like really important, because you're the average of the people around you, right?
Yeah, no, I completely agree. And an inspiring group of people for sure. I think Philip seems to be the one that's kind of driving that, at least at the moment. He's got the headlines. So we'll
So far, yeah.
So far. I'm sure it'll ebb and flow. And
well, we try to not make as much like PR stuff, because we were very secret. We're gonna have a like huge surprise launch and shit. But yeah, we'll see.
Just need to put one of your chips up on,
I'm gonna do holding the chip like this.
Yeah.
On stage and everything.
And then I have a question for Olga, from Olga, that's just come through, and she said, from your perspective, is there one small thing that we could implement in our daily /work life to make the atmosphere in Europe a bit more pleasant for investors and creative people that don't maybe have access to the funds? I think tying back to maybe some of the comments you had at the beginning around, I guess one of the benefits of people coming from Sweden as founders is they've had to go through that kind of hell of the initial phase.
Like Europe has the infrastructure, they have the capital. I think the problem is a bit of the like bashing on founders and entrepreneurs that they're bad. Like there's this like huge stigma of like being an entrepreneur, and then like if you're successful, you basically like, you're not cheered upon. Like people like want praise, yes, in Silicon Valley, like you're always trying to be the water yourself down. I think in the workplace, like be accepting of like people, being different. Like not everyone wants to conform to the people around them. If Europe, it's a cultural problem basically. If they let people like grow themselves, be a bit egotistical, but still like do it for the good of the people. Like let them run if they want to run. Don't like start putting in words like, oh well, if you're gonna run, you're gonna fail.
Yeah, don't diminish the flame, I guess.
Yeah, don't diminish things. Like there's no point. Like encourage people to do the things they want to do. That's pretty much it.
Oh, perfect. And I guess just to tie back to the start of my question, is there one thing that you think people can implement into their day, or is it a question of, I guess,
well, you can't change what other people
business?
do. Yeah, you can't change what other people do. That's, if you could, that would be mind control, and I think that would be against the Geneva Convention. But what you can do yourself is like, if you see someone being really successful, and like, you should cheer them on, even if someone's like struggling, like cheer them on.
Yeah,
and it's that simple.
Perfect. And I'm just seeing what other questions we have coming through. I think there was a comment which was pushing back on the hardware innovation, that maybe Shenzhen's a place to add to the there's an area of innovation.
Yeah, I haven't been to Shenzhen. I might visit one day.
And I guess we might have touched on it at the start, but in case there was someone who joined just a little bit late, if you maybe can revisit it, is what was the trigger that kind of made you decide that you wanted to drop out, and I guess what gave you the self confidence?
It wasn't a trigger. I told my parents before I started university that I was going to be in university for like 1 year, and then I was going to drop out and make my own company.
Man of your
and
word.
That became in like 1.8 years. So it was not according to plan, but it was more like when I got there, it was like, okay, actually, when I actually got there, I was like, okay, cool, this is kind of easy because I didn't really struggle. And then I also like the student, they call it SUBs in Sweden. I don't know what it's called in English, but I also like, okay, could I do my bachelor at the same time as my master, or like try to like double my coursework? And they just straight up told me, no, you don't have enough points. And Sweden has like this point system. It's like, you have to wait until his course is here, and then you have to wait until the exam is in like 2 months. And it's like, no, I don't have time for this. So what I did is just ended up going to like student groups, and then like a PhD group, like making drones and making rockets. And that's basically was my entire time. And then I was like, okay, cool. I'm sort of wasting time here. Like I'm not happy. I should just drop out and
do
like,
the thing you want to do.
I read the essay, like not at that point, but by Sam Altman, that like not taking risk is riskier than taking risk. And that's like when that was like bottling in my head, and I was like, okay, cool. There's no point in staying in the same place. You have to keep taking risk, otherwise you won't get anywhere.
Yeah, I mean, I feel like just through my own experience, that seems to be the biggest. Obviously, Silicon Valley is kind of like this to the extreme, but the US versus non-US cultural shift and in risk appetite seems to be the thing that always stands out to me.
Yeah, the Europe thing there seems to be more. Well, everyone's just more risk averse, which is sort of embargoed into the culture, I guess. But that's something like, be comfortable with taking risk. Just keep rolling the die, and eventually you roll the thing you want to roll, and you'll have success.
Gotta fail, gotta learn. And we have a question who's come in from Rasmus. So he said he's a master's student at Chalmers University, and he's seeing energy and efficiency as the critical bottleneck for scaling large AI models. So his question is, while optimizing hardware architecture is a clear solution, adoption is often the hardest part. How do you plan to integrate your technology seamlessly into the dominant Nvidia ecosystem, if you do, without disrupting ongoing AI training and development pipelines? And I know you referenced Nvidia earlier on. So
it's not an overnight thing. So like, yeah, we'll start with the researchers, the people doing the actual frontier edge research. Those will be the people most willing to change things. When it comes to CUDA and having this entire ecosystem that already exists, people are already moving off that to an open source standard, like using MLIR, for example, as a backend. There's this massive incentive structure to move off CUDA. Like OpenAI already moved to AMD. Like Anthropic's just using Nvidia cars, AMD cars. They're using everything they can get their hands on. So the friction is like the software layer, really. We're not trying to reinvent the software layer. We're just following the direction. If you want to make the argument, okay, CUDA will still win because they have like, Nvidia has like a bajillion software engineers working on it. Okay, sure. So does sort of Microsoft, and look where Windows Server ended up. It's Linux won in the end. Like if you're making a product for developers, you sort of have to have it be open source. You sort of have to have it be like this massive like non-centralized thing where everyone's like contributing to it. And that's like been proven in history. That's the most optimal model to do things.
Perfect. So for now, that is the majority of the questions that came through from the group that were able to join us today. So what I'll do is I will hand you back to Nihal. She'll probably go through some closing remarks. And I know she always has a question that will pop up in her head anyway, so you'll probably get a few more. And then,
Yeah.
But it's been a pleasure from my end. I'll probably pop up at the very end just to say goodbye to everyone. But it's been an absolute pleasure, Elias. And I'll leave you back with Nihal.
Cool. Also, by the way, CUDA on the Moat.
Thank you.
When I posted that on Twitter or X, people got really mad. It's always funny.
Thank you, Cameron. I have a couple of questions that I realized, actually, that would be really cool to ask him. Because one thing that always made me think was, if you take a look back at the history of AI, like when does this date back to 1950s?
Yeah, it goes back way back.
Exactly, the idea, not like the exactly something tangible. Look, how many decades we're talking about. If we had the chance to go back with a time machine, single couple of things that they missed. That's why we ended up today re-questioning all the way that we run all these models, how we, what I mean? Because we are not able to match the need versus the foundation that we need to provide.
Yeah.
Like, what do you think that, why did we miss this forks? Like, this, like the paths that we make decisions and then things change.
It's mostly just infrastructure, right? So like all of the directions everyone's going in. So we have this huge hardware bias, as it's called in AI research. You sort of have to conform what the hardware is capable of. And then back in the day, what existed was Nvidia, graphics cards, and then they figured out, we can do like math models really well. Cool, let's go in that direction. And math models and convolutions, all those sort of things are still going to be extremely important in the field of AI, but there's also a lot of more things we need to not support, but account for, I guess. So if we go back in time, basically, it's not like we can't really tell them to do something because they already know what they're trying to do is more of a mathematical problem, and they probably must all they've solved it, really. We have already all these Cambrian explosion models. The problem is not that they don't exist. The problem is that you can't really scale them because of the hardware bias. So if we can also teleport back in time, I'm sure we can figure out a way to give them the state-of-the-art XPUs, or chips, by the way, as we call it. Then they could probably scale their things much more earlier than the present. So who knows if we go back a few decades, like what would be the societal impact of like dropping this like state-of-the-art technology today on them? I don't know, and I don't think we should mess with timelines because time travel is really wobbly, I guess. But if we did that, then we would accelerate that timeline quite drastically because it's exponential. So I'm not even going to guess what it's going to look like.
Because I sometimes think the markets or the society have a tendency to prioritize economics over physics, over that the longer term benefits, and that's most of the times root causes of all these lock-ins or all this like persisting on something, but then we don't stop and question and say, hey, actually this can be done better.
The thing is with the market is like the free market, like economics purely, it's a chaotic machine. It won't always be perfect. It'll sometimes overshoot, it will sometimes undershoot, but at the end of the day, the market always corrects. So when we show up with our chips and then people can use them to scale whatever models they're trying to scale, that won't be an overnight thing. It won't be like instantly $20 trillion landed in our bank accounts. It will be like maybe a decade thing. So the market sort of, LLMs are plateauing. The market will self-correct. It might be bubble burst, but it won't really be a bubble burst, but people will keep working on AI technology, and we've already seen what's possible. And I don't think this is going to be a massive bubble burst because of all of the downstream economic value that we already are getting from these models. But it's basically going to be another exponential of market growth.
And if ZettaScale fails, let's say in the future, what would be the root cause, you think? Or what would be the biggest assumption that caused it?
I don't know, something terrible happens. I get hit by a bus or something. I don't know. Or like our chips randomly explode because of physics, which is quite improbable. Like if it never existed in the first place, Nvidia would become the next Intel. The market would still converge. People would have taken longer to realize that we sort of need these more diverse models because different models are better at different things. The market adjusts. The incentives are still there, but when it comes to auto dying out, that's never gonna happen.
I kind of sense that you would end with this sentence.
Like it's a
similar
non-zero probability that I get eaten by a shark tomorrow.
like out of your control, forces out of your control. If you like physically disappear, that will be the end of ZettaScale. I think it's a perfect way of looking at it. You start to bring it to there's even not a finish line, but then you start to put your impact in the world, not to, okay, I'm out now.
Yeah.
Like, awesome. Actually, I'm gonna invite Karen because we have a tradition, and it's time to do our little tradition. We ask our previous guest to pose a question for the upcoming guest, and in this situation, you have a question from Ashi. Ashi is one of the co-founders of Psyop. I'm surprised you guys know each other.
No, we all know each other. Silicon Valley is a small place.
Way smaller than we think.
Yeah.
So, Ashi's question for you is the following. As a CEO, how do you juggle between all the tasks and still stay sane?
Stay sane. Okay. At Zetta, we have this thing called full autonomy. So I don't give a shit how much you work or when you work, as long as you get stuff done. And it's up to you to not burn out. I think for me, it's just having a nice routine of like waking up, even though my sleep schedule might not be perfect, and like going to the gym, exercising, keep eating healthy, and yeah, that's it. You know, I might try fencing. That might be fun. Might do let on some frustration, but
fencing.
I did that, or it's my partner. That's it.
Yeah, my partner got me into climbing, so I understand the whole kind of getting into their hobby.
I mean, yeah, being a partner is very important. So like they support you. So
absolutely, keep you grounded. Tell you when you're being an idiot sometimes.
Exactly.
And probably also it's the only person you call up, right? When you feel like, oh my gosh, did you hit the wall?
Yes.
Let's just you go to person. Yeah, very happy that you found your partner in crime. Yeah, amazing. Do you have any sort of thing that you wanted to say, but we didn't happen to ask you? Perhaps for Deeptech founders or anyone who wants to achieve something meaningful?
I can't think of anything, but a cool thing to ask is like a common question I get, like, okay, don't you need like billions of dollars to do this thing? Because chips are expensive, right? No. Okay, so I'm going to leave with a few contrarian takes. CUDA is not a Moat. That's a massive Psyop made by Nvidia to increase their stock. LLMs are not AGI. They are plateauing. And we sort of need to keep doing AI research to reach AGI and ASI. And the notion of that you need a lot of capital to build hardware is fundamentally stupid. And if you do that, then you're just having a huge inflated round. And you raise $1 billion, and then you're just going to waste all the money.
I think we got some YouTube shorts out of that now.
Okay. I'm excited to read the comments. I'm very excited to read the comments now.
I think you have this a lot. Thank you. For conversation. But Cameron and I, we both believe that if you want to achieve something, even if it is the chips, one of the most critical technology right now, from or watch the fridge to cars, like everywhere, you just go for it and then try to be resourceful about it. And especially right now, building is not the problem, like, right? Like to make decisions around what's going to make a difference is the differentiation and the courage of yours, like people like you.
I think it's the conviction, right? The barrier to entry has been lowered in so many areas. It's having the conviction to actually move forward with it, at least from my opinion, to a degree.
I just like building things.
Yeah. Exactly. Thank you so much for being with us today and sharing your experience, your insights, your life story.
Of course.
I have a
Thank you for
feeling
having me.
we're gonna knock on your door again in the future to see how you're
Yeah.
doing and how things are going.
Come by the office, check out the cluster as well.
Absolutely.
Oh, we for sure.
All right.
Super.
Perfect.
Thank
And
you.
then
Awesome. Yeah, thank you for
just,
having me. Good conversation.
absolutely. Thank you very much.